Hey everyone, my name is Christine Javier, and today I'm going to work on Free Code Camp's Caesar's Cipher. So essentially, let me just read through this. Caesar cipher, also known as a shift cipher. In a shift cipher, the meanings of the letters are shifted by a some set amount. So a common modern use is a Route 13 cipher, where the values of the letters are shifted by 13 places. Thus, A turns to N, and B turns to O, and so on. So they want us to write a function that would emulate that ciphering. Now, this is important to note. All letters will be uppercase. Do not transform any non-alphabetic character. Okay, so that's really, really key to our situation here. And I gotta say, this function was a lot of fun for me, at least. It involved, implementing methods. It made you think about ASCII, regex. It was cool. So yeah, let's go ahead and just copy this function here, and I'm gonna work in my text editor. All right, so now let me just. This is how I like to start with situations like this. Essentially, the trend is gonna go like this: we get a string. We want to manipulate that string. So in order to do that, we want to make it into an array. So string turns into an array. We manipulate elements of the array. We turn it back into string, and then we return the string. Okay, so I'm just going to write that line out. I'm going to set it equal to str. str equals str.split. Now all the elements of that string are put into an array and are now capable of being manipulated. I'm going to map through that array and apply my manipulation somehow. And after manipulating is all said and done, let's go join that array back together so that it becomes a string. And this is just like my one line, very broad outline of what we're gonna do. So the key here to this function is this here. What are we possibly gonna put inside map so that every element is manipulated that way? Well, I'm going to declare a function, and I'm going to call it Cipher. All right, Cipher is going to take in an input. Let's call it a letter, actually. Now, what's the first case we need to look at? Well, we know that we shouldn't transform any non-alphabetic character. Don't transform it because we want to pass it on. All right, so how do we account for that? Well, this is a call for trusty regex. I don't want you to see the answer, but I'll just show it to you anyway. I did this earlier. And what I did, I put a test string of various alphabetic characters, as well as white spaces, numbers, and random symbols that are non-alphabetic. I just tested my regex here, and as you could see, everything that isn't alphabetic is highlighted, which is what we want. And just really quick, this caret here means not. So everything that is not lowercase a through z or uppercase a through z with a global variable, let's tackle that on. Let's find all those instances. So I'm just gonna declare that regex. I will call it symbol regex equals. This is how you do the syntax. You do 2 forward slashes, and you append the g at the end. Let's work on the body of the regex. So let's do the caret, lowercase a through z. And actually, you don't even need to include this for the purposes of this particular function because all the test cases are going to be capital anyway, so you won't even come across this. But might as well. And there you go. Add the semicolon at the end. Good. Now we have our regex. We have a way to pinpoint throughout the entirety of, throughout this letter input, whether or not it is alphabetic or not. Cool. So now let's write an if statement to test for that. So if letter, or I'm going to use something called the test method. So we're trying to say, is letter a symbol? Is it, so in order to answer that question, we're going to use test. And the way test works is you want to do the regex that we're testing for. So we're going to do symbol regex dot test, and then you're going to put the string that you're testing for. So we're going to do letter. And this here, this is going to evaluate to a Boolean. It's going to say, oh, is this true or not? And if it's true, what are we going to do? Well, I just want to return the input. I want to return letter because we don't want to manipulate it anyhow, but we still want to keep it in our ultimate answer. Okay, so this tackles everything that is non-alphabetic, which is great. Now, let's work on everything that is alphabetic, though. This is when kind of the greater thinking comes into play. And you could technically write an else statement and everything else that you want to put, but you don't need to, and I just won't. All right, so now let's see. So ASCII, this is where the fun comes in. So for rot 13, you want to move 13 places. So with the letter A, you want to evaluate the ASCII code. The ASCII code for A is 65. You want to add 13, so go down all the way 13. And then you want to retranslate that back into a character, an alphabetic character, and you'll get N, which is exactly what we want, and which is awesome. However, there is a caveat to this. Let's say we're at the letter N. Let's just say that. Let's do the same thing we just did with A. Translate N to ASCII, we get 78. Add 13 places, we're at 91. Let's evaluate that back to a character. Oops, we get a left square opening bracket. What's happening with that? Well, we're not recycling like we should. We want to just stick within all the uppercase values of alphabetic characters. So essentially our goal here is to say, hey, once we're at the letter N, let's go back and recycle at A. So that N matches with A, O matches with B, P matches with C, and so forth. Well, how do we do that? Well, let's reevaluate. If our goal is to translate N to A, let's evaluate the process in which that could happen. So we're at N, let's evaluate the ASCII, we're at 78. We want to get to A, so let's look at the ASCII of A, 65. What's the relationship between 78 and 65? 78 minus 65 equals 13. Okay, so we got a little pattern going there, or a little like hypothesis at a possible pattern at least. Let's look at O. We want to evaluate O to B. O's ASCII is 79. B's ASCII is 66. What is 79 minus 66? 13. And that holds true all the way up to Z. And it's going to cause a cycling from A to Z, and not outside of that, which is exactly what we want. Okay? So the first thing we should do, though, with that logic in mind, is, well, let's translate the letter into its ASCII and manipulate that from there. So I'm going to declare something called code. And you could even just put ASCII, code ASCII, equals, it is, I believe it's input.char code at, and you just want to put in the 0th element, and this makes sense in this function because letter is only just one element in one string. So you're always going to target the 0th position. But in a hypothetical situation where you have a long string, you would have to consider all the characters you want to like evaluate the codes for. Okay, but it just makes sense here because 0 matches with just the one letter that's going to be inputted. Now I just want to check to make sure this is even working. Let's just return code ASCII. And I'm going to console.log the Cipher function with the test of A. All right, so we should be getting the ASCII code of 65. Capital A is 65. Let's run that. Input.char code. Input.char. Is it char at? Input.char code. Input is not defined. Oh, my bad. It's a letter. Duh. Okay, so let's run that. 65. I put input. The input is actually the parameter letter, so that was my bad. All right. So now that we have the ASCII code like we wanted, we're going to create some conditions. Well, if code ASCII is greater than, now let's look at the limit. 77 plus 13 is going to equal 90. 90Z. So this is our limit here. Anything past 77, we have to recycle. Okay, so if code ASCII is greater than 77, simply what we're going to do is subtract 13 from code ASCII. And code ASCII will become code ASCII minus 13. Okay, now otherwise we're going to just add 13, right? Cool. Now, so we're at this point where we've translated our letter to an ASCII, and when it's anything past M, we're subtracting 13. Anything N and further, we're subtracting 13. Anything M and below, we're adding 13. So we're at the point where we've translated. Let's translate it back into a letter. Now to do that, you're just going to do something called string dot from char code, and then you're just going to input the code ASCII that we've now changed. And we're simply going to return that. Okay, so let's console.log this here with the cipher with A. A should have 13 added to its ASCII code, and then we're changing it back into a string so that it becomes M, or N, yeah, sorry. A to N, yep, that makes sense. But now let's see what happens when we get the input of N. What's gonna happen there? We're gonna get A. So the recycling does work, which is exactly what we expected. Cool, so let's see if it works in the context of rot 13. So after Cipher is applied to every element of the array through map, it should be joined and returned as a string. So let's see what rot 13, this funky set of letters, is going to evaluate to. Free code camp. Pretty cool, huh? Cool, so let's copy that function, add it into free code camp, and see what happens. Cool, so it totally works. Hopefully this was fun for you, as it was for me, and hopefully you have a good day.